All right, everybody. Sorry for the technical difficulties. It's undoubtedly, it's bound to happen when you're doing live shows. So, what we've done while Philippi resolves his microphone issue, what we're going to do is we're going to move on to the next session. So this is going to be, we are going to be talking now how RTThread can improve your embedded system projects. So this talk is by Ma Jianjia. I probably pronounced that wrong, so I'm sorry. But please feel free to introduce yourself when you do go live here. They are a research fellow in the University of Southampton. They're a hobbyist and open source project contributor. So again, the talk is going to be here how RTThread can improve your embedded system projects. So with that, I will hand it over to you, Ma.
Yeah, thank you, Jacob. Let's wait a little bit for my PowerPoint, for my slides to upload. Take a bit of time. Can you hear me?
Yes, we can hear you.
Okay, yep. Good. Thank you. Thank you. So my name is Jianjia Ma, and today's presentation I will talk about how RTThread can improve your embedded system project, especially from a user's view. Next. First of all, who am I? I'm currently working as a postdoc in the University of Southampton. My research is about building a portable feedback system for people use in CPR rescuing. So when a person is suffering cardiac arrest, people need to press their chest to pump their blood and clear their airway. So this system is to help them to do better compress. So therefore, to help to improve the survival rate. So personally, I'm an embedded system engineer for both hardware and software. And my personal interest is machine learning in microcontroller, robotic, and sensors. So my connection with RTThread can go around 10 years ago when I just finished my learning of C programming language, and I wanted to learn an RTOS. And I searched online, and people recommend RTThread over MuleCourse, which is on every textbook back in China. So then I thought, why don't I just choose this one to learn? So during these years, I built a lot of things out of RTThread. Because the 4 projects below are a part of my buildings. You can see 2 drones. The second one is actually my graduation project, and it has 8 MCU, 8 STM32 on board. All of them are running RTThread, including the motor control. And the third one is an hi-fi player. It's also using the RTThread and its GUI at that moment. And the final one is my PhD's project, which is a low power sensor with Bluetooth connection to monitor exercise remotely in patients' homes. So now I'm also became a contributor of RTThread. I write software package, then submit to RTThread, and I also help them to do debugging. And the highlights of today's presentation is I will first introduce a little bit of RTThread. I believe most of you already watched the previous presentation and have a big ideas what RTThread is. And then I introduce a few more features that I think most convenient and useful for us as a user. So let's start with RTThread. So why are you using RTThread, or why am I still using RTThread? The top reason is the code usabilities, because RTThread has POSI and libc environment supported. So I can just write my code in a standard C style, and then it can work on all the platforms, including STM, NXP, or even RISC-V. And the second one is it got great tools. You already saw some introduction about the RTThread Studio. That is the one I currently like very much. And it got scones to build the project, and it has the env for the environment setup as well. And finally is the package. I do not want to reinvent the wheels every time, so having third-party package is a great plus for this. And next is again from a user point of view, I can see there are 3 different support levels for the RTThread system. The first one is the kernel, which is maintained by the RTThread teams. It provides the fundamental functions of RTOS, including inter-thread communications and memory allocations things. And the second part, which is why the RTThread different from the other RTOS, is it got its own frameworks, a lot of frameworks, including the driver framework and net and a lot of things. It's mainly maintained by the RTThread team. So during years of development, these 2 parts are generally stable, but there's still some updates in the components from time to time. And the final part is reason that RTThread can grow within China during the years, because a lot of support package for RTThread, some of them working very closely with the component level things. So it's very convenient to use, which I will introduce a little bit later. And so with all the components and the package, we need to find a good way to configure them and to use them, right? RTThread provide great tools for env, which is an environment configuration for the RTOS, for the RTThread. It can configure and generate project for Q or IR or other GCC-based environments. In recent years, RTThread also make their own IDE out of Eclipse, which is a famous text editor. And now we have the graphical views to configure our package and the configurations. So from now on, I will start to talk about a few different features that I think is most important for us. The first one is the mesh. So the mesh is a key, it's a very handy shell in RTThread, which I like very much. To provide your the capability to interact with your applications. It works just like a console in Linux or a shell in Windows, but it's more like the console in Linux. We got a few system commanders like the PS and free for the memory, and a few more for the file system. And also you can customize your own commanders, and it's very easy to download. I'll introduce it later. It can allow you to debug your system or your application on the fly. It's in fact it's a function in your application, so it can access all the resources. It can change your system stage. It's very useful when you come to debugging like the motor driving, which doesn't allow you to use like breakpoint to stop the of your applications. So so another thing that to be noticed is all the not all, most of the RTThread package and their components already have some commanders that written in there. You just need to open it, and you can have like very detailed debugging information out from the shell, or you can also do the interaction to change the stage, change the configuration within the package on the fly. And additionally, user can still use the regular print or the more advanced log to print or log your information onto the shells. The detail manual is showing below in the link. So next, I will. So this is a way to write a customized shell commanders. You can see it's very simple. The only thing you need to do is add a macros after your functions. Then after that, it does all the job for you and converts the function into a commanders. For example, here, if you have a function called hello, then put the name in here, then hello will be your commander. Here is some description of this thing, so that when you want to see the whole list of commanders, you can have a more description here. And if you want to input some argumentation to your commanders, so this is the way you want to do it. It's a standard C programming way to do it. So the next feature I want to talk about is the package for the RTThread. It's also the ecosystem of the RTThread. Because so many package available, if you know what you are looking for, you just go to the web portal. Then this is where you can find all the package available. For example, if I'm looking for my contribution, which is an Nnon package, then I just put it into the search box, and it will grab my project introduction from my GitHub. So you can have more information here. And the package link is down below. And alternatively, in the RTThread Studio and the ENV, you can see the full index of the package. Personally, I prefer this way to find package because I can see all the related package at the same time. For example, in one of my projects, I need to use the Pi-hole MQTT. Then later, I found it is not that suitable for my application due to some minor issues. Then I just come back here, and I can immediately see there's lots of other MQTT package that support these functionalities. So I can just take a box and everything done. I can switch the package on the fly, and RTThread Studio or the ENV will manage that for you or for me. So again, as a user's point of view, it might not be accurate. The package that's supported by RTThread can be classified into two different types. One is the official maintained package. So this package normally have deep connection with the component level framework. Some of them is written by the RTThread team, so it's more the compatibility is very good. And others are famous package that use anywhere, any other way. So they are maintained by the official teams as well. So the other types are the community contribution for the user, such as me, to contribute my package there. Most of the package are in this category. So because RTThread has a good support of proxy and network or the file system, So porting small Linux programs into RTThread can be very easy. So it shouldn't be surprised that RTThread mesh kernel has an VI editor package in there already. So if you are interested, you can go there, go to the package and download it, have a try. It's very fun to do it. So if you wrote something very good and you want to share with others, so you can submit the package to the RTThread index, package index. This is the way how you do it. Just add a scroll file to your software if you don't, if you didn't already use it, and then publish your package to the public domain as usual, such as GitHub. Then fork the repository of the package index. Then check, then add your package informations, and just submit the pull request. So the full tutorial can be found in the link below. And next, I will talk about two, I will say two examples of the framework in RTThread. One is the network, and the other is the device framework. They are, I would say the structure is very common and used all around the RTThread. So hopefully it can give you more information beside the previous presentation by other peoples. So first, for the network, RTThread provides POSIX interface and the BSB socket interface is very useful. It means your code, your application level code doesn't rely on the low levels. And what is more commendable is RTThread provide a level called socket abstraction layer. So what this layer does is to unify the interface between different network devices. For example, some high-end chip might have Ethernet built in their chips. Then if you use an IT stack like the lightweight IP to do all the socket and to do all the internet connections. And some of the low-cost platform doesn't have it. And then you need to use some IoT modules like ESP A266 and the SIM 800 to manage the internet connection. So for this module, they normally have their built-in IP management and socket management. So with that kind of module, you don't need to run your IP stack in there. So the SAL does is to unify the access of it. Therefore, we can use the POSIX on it. So next page. So here is a structure. Again, is from my understanding, it's not official. So allow me if there's some mistake. So if we want to do our web programming, POSIX is the only thing that we care about. So after this is managed by the RTThread. So the SAL can select to access the lightweight IP or to the AT server for the socket if we want to program the socket. Then it come back to here, which is AT device. So in the devices, AT devices, we got a whole list of device, a whole like 20 common modules, including Wi-Fi modules like this one, and 2G, 3G, 4G cellular modules like the SIM. And they are all ported to the series device framework by the RTThread. So what you only need to do again is to tick the box on the configuration panel and to select different supporting without changing any code on the application side. So next, okay, again, it's a a nice framework called device framework, which in fact the network is based on the device framework as well. So I think it's also very important to give you an idea about it. So in RTThread, we got something called device driver, or we call it device. It is a unified driver for hardware interfaces and virtual devices. Hardware interface including UART, SPI, and all other hardware interfaces that can exchange the data. Virtual device includes block device for memory and network device and sensor device. So why this is important? It enables user to use standard read and write operation to do the application level programming. What is more important is RTThread need to it provides a unified interface for RTThread to manage shared resources. For example, if we want two hardware sensors to use the SPI at the same time, the RTThread will manage the automatic access to the interface for us. So also, user only need to implement once of the low-level device to use all the check that the RTThread can provide to use, like the sensor framework or sensor device. So again, I will explain the whole framework using the file system as an example. So yeah. So again, what we want to do is only do the programming on the high-level application level, which has the POSIX support. Then we don't need to do anything about the medium level because it's all managed by the RTThread. So what we only want to do is we need to ensure the low-level driver is presented. So for example, if we want to access SD card, we will need to have implement the SDIO driver implemented. Then again, tick the box on the configuration, select one of the file system you want, and select one of the driver that match your low-level driver. Then this file system will almost running. In fact, in the RTThread, most of the commands driver are already implemented for popular MCU such as STM and NXP and a few others. So probably you don't need to do anything, just tick the box and the file system will run. So finally, we come to a little summary for the RTThread. Then why use it? Because it got good POSIX support, it got a libc, the package. Therefore, I have very good code reusabilities. I don't need to write the codes across my project. And it got very good tools to help me to develop. The Scones Studio is very easy to use. And it got a very large ecosystem, a lot of package for your selections. And I believe we still have some time. I will go through two of my open source projects, and they are built on top of the RTThread, or they are built with the help of RTThread. So the first one is Nnon, which stands for Neural Network on Microcontroller. So it's a neural network inference framework that run on top of MCU. It allows you to run a quite complex neural network on the MCU, And I present this package on the TinyML Summit 2001 early this year. If you want to check the presentation, here is the link to the presentation. And you can also find more detail on the repo. So by using RTThread, I have like an environment. Again, I have proxy environment, I have libc environments, so I can run the code out of RTLS directly on my PC or anywhere else. So during the development, I also use the mesh shell to transmit data file to the microcontroller. It supports a Y modem, so I use Y modem to transfer the data to the MCU for the data validations. I also use the console to interact with the library, so I can control it. I also use the memory debugging method that provided by the RTThread, so that I can find the memory leak very easily. Next, I will show you an example using this framework, which is using recurrence neural network to do human speech noise suppression. In short, it will suppress the noise in the background for you. So the example is running on top of the STM32L476 and RTThread, of course. And let's see the videos. So this is noisy speech. So this clean speech. So that is the example. If you want to see online, so here's the link. There is another demos, which is the keyword spotting. It can the MCU can detect the keyword in the speech, like up, down, or left, right, things, or 1, 2, 3, 4, 9. It's very interesting. And if you want more document about this example, the repos is here. Just go to my name and Nnon and find the example. So next, I will talk about another my open source project. This project is a little bit different from the previous one because the previous one is only a software package. So this one is related to hardware and system design. So it called Chik Station, which is an ultrasonic anemometers and weather stations. It got a lot of things inside there. So here is the features of the Chik Station. The system is very small, but the sensor integration is very high. It got multiple sensors such as IMU and gas sensor, ray sensor, microphone, RGB light sensors, and barometers, humidity sensors. All the sensors are mounted on the one of the I2C or the SPI. So we need atomic access on the physical interface. So RTThread helped me to do it. Also, thanks to the AT devices, the abstraction of the network, I can easily enable many different external IoT modules, such as this one. There are also very good functions that I don't even need to do a single line of code programming that I can enable that, including the USB CDC or USB mass storage class and CAN bus communications, UART communications, and all the drivers and also there's some other function like the RTCs just can be enabled if you tick the box. And most of the application codes I wrote for this is reused from my previous project. Again, it's a benefit for epoxy and LabC support, such as the data recording and some sensors driver. So I cannot finish the whole project within 2 or 3 months without the help of RTThread and its good ecosystems. So which allows me to focus on the most difficult part, which is the signal processing for the ultrasonic transducer array. This project is fully open source. You can find all the source code and build the log in the repository here. And there's also a mirror version that shows in the Hackaday.io. And next is small videos that I demonstrate the system. So it's a test in windy days. I set up 2 solar panels and a battery to allow it to work overnight. So it's transmitting data to through my home Wi-Fi to broker, to an MQTT brokers. Okay, so finally is the summary of the presentations. I want to talk a little bit about what I expect and which I didn't try in RTThread. There's still a lot of things, very interesting things happening here. And like the first one, the Rust is going very popular and these days, especially in the embedded system as well. So in RTThread, you can actually build Rust code and call the functions inside it, or you can do it in the other way around. The good things with RTThread is already exports a lot of system functions. So it means that you can call this function in the Rust code as well. So this is very interesting. The second one actually came out many years ago, but I didn't try it. It allows you to load codes from your file system into the RAM memory and execute the codes inside the RTThread. It's very useful when you don't want to update all your application, but you want to have some small update of a little functionalities. Like if you want to improve your algorithms, it's a very useful way to do it. The third one is the microkernel. I don't have much knowledge about that, but RTThread team is working very hard on this, so hopefully there will be something coming out soon. And finally is for users, other users as well. The global semiconductor shortage is yet to be end. So if you are looking for some alternative MCU or some local MCU that originated in China, I think RTThread is a good starting point because there might be more connection for the RTThread to access with these chips manufacturers. And if you are new to the RTThread, here is some suggestions, recommendations. I would suggest you to stick with STM32 because it's most supported hardware. It got a very good coverage of all the low-level drivers, SPI and everything, yes, including RTC and a lot of things. So Then you need to get one of the officially supported boards, such as the ARTPi. It's actually built based on STM32H750, so it's a very powerful chip as well. And if you are not familiar with scones, go with RTThread Studio. It's easier. Also, to read the example, most of the example already have some codes that good commenting there. You can understand it very easily. And keep an eye on the RTThread's Medium account. So there will be update from time to time. Yeah. And okay, finish. And thank you for my coming to my presentation. And I welcome any questions. I'm happy to answer that. Thank you.
All right, thanks. Yeah, great presentation. Thank you very much.